Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Wanasi. My matrix number is B1125102799. Today I would like to talk about our work assignment, which is our group has been given a topic for transfer function, which is for part B, and also for board plot is part G. So for introduction of transfer function, a connection between a circuit's inputs and outputs in the frequency domain is represented by a transfer function. It is employed to examine how a circuit responds to various frequency. The transfer function is shown schematically by a board plot. It consists of a phase plot and a magnitude plot that show the circuit's phase shift and gain across a range of frequency. In part G, the poles, zero and corner frequencies of the provided board plot are identified in order to calculate the relevant transfer function. We go to the next part.
Assalamualaikum and very good morning to all. My name is Muhammad Shukri Abadi bin Rosli. My matrix number is B1125102777. Today I'm gonna explain how to convert a transfer function given into a board plot. So the transfer function given is HW equal to 500 JW divided by JW plus 3 multiplied by JW plus 40 in power of 2. So for the first step, we need to rewrite the transfer function given into a standard board plot form so that the corner frequencies can be identified easily. So as we can see, the numerator is 500 JW, which is the 500 is actually the gain that we can put in the formula of magnitude gain equal to 20 log K, which is the K is 500. And the JW is 0 at origin because it doesn't have a number in it. And for the denominator, we actually can factor out the 3 and 40 from its original equation. We can separate them to make easy calculation. As we can look at the paper I just write. So after we factor out the 3 and 40, we can get the new transfer function, which is 500 JW divided by 3 multiplied by 1 plus JW divided by 3 multiplied by 40 in power of 2 multiplied by 1 plus JW divided by 40 in power of 2. So we can take out all the number which is in the left side. We can get 500 divided by 3 multiplied by 40 in power of 2, and on the right side we can just left the imaginary number, that is JW divided by 1 plus JW divided by 3 multiplied by 1 plus JW over 40 in power of 2. We can actually get 0.1042 JW divided by 1 plus JW over 3 multiplied by 1 plus JW over 40 in power of 2. After we get the new transfer function, we can identify the magnitude gain by insert the new gain in the formula, which is 20 log K. So as we can see, K is equal to 0.1042, and we just insert it, 20 log multiplied by 0.1042, and the number will get negative 19.64, which is that is a magnitude gain that we can plot in the board plot. After that, we need to identify the poles and zeros. The zeros cause the magnitude graph to upward, meanwhile poles will make the graph downward. So it is easy to identify the poles and zero, which is when you see the fraction based like this, we just take it and name it 0 and pole. We can identify the zeros. As we can see, it's only in JW, and based on the table, based on the board plot table, it is in 0 at origin, and the slope will be plus 20 dB per second. And after that, we can identify poles, which is there is double pole. Pole 1 is 1 plus JW over 3, and pole 2 is 1 plus JW over 40. So we just take out the pole, which is pole 1 is 3 radian per second and pole 2 is 40 radian per second. Based on the board plot table given, we can know that the JW itself will have a slope 0 at origin, and its contribution will plus 20 dB per second. So we just start from negative 20 into 0 at 1 into at 1, and will upward into plus 20 dB per second. And for the poles, we can look it as double poles, which is in WP1 equal to 3 radian per second, and pole 2 equal to 40 radian per second. For as we know that the poles will be downward, so for the 3 radian per second, it will contribute negative 20 dB per second after 3, and just like 3, 40 radian per second will have negative 40 dB per second after 40 radians per second. We can write the expression to make it easier. As it goes, sample 0 will upward the magnitude and the pole will downward again. So this is our new Belk plot graph after I summarize the magnitude gain, the zero error origin and simple pole. So we start the slope at negative 19.64. After the zero error at origin, it will plus 20 dB per second, and as we can see that the simple pole 1 plus JW/3 will stay linear or no upward or downward in the graph. So it will stay linear at 0 until hit 40 W. After that, the pole 2, which is 1 plus JW/40, will be downward because of the when 0 minus 20 is equal to negative 20 dB per second. So the graph will go downward until it reach negative 40 dB per second.
Okay, Assalamualaikum and hello everyone. My name is Muhammad Shafiq. Today I would like to explain and represent about method analysis spot plot to transfer function. So our question is G. The first one, we need to know how to read, label and draw and do the magnetic spot plot. Okay, first we need to know what is the horizontal axis. Horizontal axis is the angular frequency, which is omega, and vertical axis is the decades decibel, dB. Okay, first we go to the first section, which is positive dB per decades. How to get this answer? So first we need to know which factor we need to use. So we saw that the answer is 20 dB, right? So we need to use the 0 at the origin, because the slope is positive 20 dB per decades. Depends on the answer. So the answer is 20 dB. So we draw from the 0 at origin to the straight line to the point 1, because the answer is at angular frequency 1. So we draw the straight line. So we get 0, 0. Later I will explain. Plus 20. So we get that 20 dB decades. The answer is 20 dB slope. Okay, let's go to the second section. Okay, the second section, we know that we have the 20 dB, right? 20 dB positive. So how to get constant, which is this is constant 0 dB. How to get 0 dB? So we need a negative 20 dB slope. So from the 0 point, which is the first point. So from the 0, and then from the 1, we start to negative slope, to 20 dB slope. So we need to use function of simple pole. This one 1/1 plus JW per P power n. N is 1 because we need to use negative 20 dB only. So from the constant 0 and the pole 1, so the starting point pole 1, so the slope is down. So now we have 20 positive dB plus 0 is called next for the next question, and negative 20. So we get constant 0. So we get the answer. Constant is 0. And then the last part for me is negative 40 dB per decades. So how to get a negative 40 dB per decade? First, we know that same. We know that we have the 20 dB per decades, and we have negative 20. So how many dB left to get negative 40? So we need to negative 40. We need to another negative 40. So we need to use the same factor from the table. We need to the same factor, but the important thing is the slope is negative 40, right? So we need to use the n power 2. The n is 2 because we double it. So the answer is 1/1 plus JW per pole. Okay, this one is important thing. Which pole? Last time the pole is start from 1. Then this part we need to use the 8 omega. So the answer is 1/1 plus j omega over 8 power of 2, because the answer is negative 40 slope. So we have 20, negative 20 and negative 20, so we get negative 40 dB per decade. So first one is 20, and then we get a constant, and then we down negative 40. So the answer, the first one is j omega. The second one is 1/1 plus j omega over 1, and the last one is 1/1 plus j omega over 8 power 2. That's all for me. Thank you.
Assalamualaikum, my name is Muhammad Arif bin Effendi Nazila. My metric number is B1125N278, and I will talk about the step 4 until the final cert. So for the step 4, we analyze the change at the omega 30 radian per second. At omega 13 radian per second, the slope changed from negative 40 decibel decade to negative 20 decibel decade. The slope is increased by 20 decibel per decade, and increase of 20 decibel per decade indicates 0. Thus the factor is equal to 1 plus j omega over 30. This 0 partially compensates for one of the poles. So for the step 5, we analyze the change at omega 100 radian per second. So at omega 100 radian per second, the slope changed from negative 20 decibel per decade to negative 40 decibel per decade, and the slope decreased by another 20 decibel per decade. This indicates the presence of one additional pole. Therefore, the factor is 1 over 1 plus j omega over 100. So after this, the frequency, the final slope become negative 40 decibel per decade. So for the final step, we construct all overall transfer function. We combine all zeros and poles identified from the slope change, and the transfer function we can see at the slide, where K is the system gain determined from the magnitude level.
Hi, Assalamualaikum. My name is Muhammad Syariman bin Syarizan, number metric B112510272. So I'm going to present about discussion and conclusion. For discussion, this assignment focus on analyzing the relationship between transfer function and Belk plots. For transfer function, which is we choose B, the magnitude and the phase equation were derived and used to construct the corresponding Belk plots on semi-log graph paper. The corner frequency and slope were identified to determine the effect of poles and zero on the system response. For magnitude Belk plot, we choose G. The transfer function was obtained by examining the break frequency and change into slope shown in the graph. Then the results show that in the characteristic of system in the frequency domain can be accurate represented using the Belk plots and transfer function, and making them useful tools for circuit and analyzing and design. For conclusion, in conclusion, this assignment improved our understanding of frequency response analysis using transfer function and Belk plots. We successfully derived the magnitude and phase plot from transfer function B, and determined the corresponding transfer function magnitude of Belk plot G. Through this process, we learned how poles and zero affect system gains and phase characteristic, and how Belk plots can be using to predict and analyze circuit behavior. Overall, the assignment enhanced our knowledge and practical skill in frequency domain and analysis of electrical circuit. That's all for me. Thank you.